Hi everyone. So in the last video we have learned about atomic radius. So in this video now we are going to learn about the ionic radius. So actually the ionic radius is the distance between the nucleus and the electron in the outermost shell of its ion, not of the central atom. So we can just define the ionic radius as nucleus and the between the nucleus and the electron in the outermost shell of an ion. This is the most important word. That's the reason why we call it as ionic radius. So actually the difference between the ionic radius and the atomic radius is atomic radius is the distance between the nucleus and the electron in the outermost shell of a neutral atom. But here in the ionic radius, we'll measure the distance between the nucleus and the electron in the outermost shell of an ion. This ion word is very... So we know that ions are of two types. That is cation and anion. So the variations in cation is the ionic radius of cation is always less than neutral atom due to decrease in the electrons and increase in number of protons. Like if we take one example, like Na is the neutral atom because it has 11 protons and 11 electrons, but whereas Na plus we have 10 electrons but 11 protons. Here we have more number of protons than electrons. So what happens is here the nuclear charge increases. In the neutral atom we have no nuclear charge, but whereas in the cation we have more nuclear charge. Due to that reason, the size of the cation is always less than the neutral atom. That is, ionic radius of cation is always less than the neutral atom. But whereas coming to the anion, ionic radius of anion is always greater than the neutral atom. So if you just take an example like Cl. So here Cl has 17 protons and 17 electrons. But whereas in the Cl minus ion, in the Cl minus, we have 17 protons but 18 electrons. Here what happens is the nuclear charge, that is the number of protons are less than the number of electrons. Due to that reason, the nuclear charge is less in the anion. So if the nuclear charge is less, the size of the atom will be more. So ionic radius of cation is always greater than the neutral atom. So the order of the ionic radius will be as anion greater than neutral atom, always greater than cation. This is the most asked question. So by taking an example, we can say that I minus is always greater than I plus. And the trends and variations of this ionic radius across a group are so as we move down the group, the number of shells increases. So the atomic radius or the ionic radius increases, like lithium plus, Na plus, K plus, and rubidium cesium. So as we move down the group, the ionic radius also increases as we move down the group. Increasing ionic radius. It's seen like the atomic radius, but whereas in the period it decreases, like Li plus is greater than B2 plus greater than B3 plus carbon 4 plus greater than, and so on. And the most important point to note here is the star mark point. H plus is smallest ion in whole periodic table. But whereas Cs plus is largest cation, it is cation. Cesium ion is the largest cation in whole periodic table. And H minus and I minus are the smallest and the largest ions respectively. Like hydrogen ions, hydrogen anion is the smallest anion, whereas the iodine ion is the largest ion. In this topic of ionic radius, we have another subdivided topic called isoelectronic spaces. Isoelectronic spaces are nothing but the spaces which are having the same number of electrons irrespective of protons. So we can just define it as the spaces which are having same number of electrons irrespective of protons. That means it doesn't matter whether the protons are equal or not, but the electrons should be equal in the isoelectronic spaces. Example, you can just take an example like F minus Ne, that is neon, and Na plus Mg2 plus 2 Al3 plus, like that. This is the set of isoelectronic spaces. Here we have 10 electrons. Here also we have 10 electrons. We have 10 electrons everywhere. But if we see, the number of protons differ. Here we have 9 protons. Here we have 10 protons. Here we have 11 protons. Here 12. And here 13 protons. So it doesn't matter whether the protons are equal or not, but the electrons should be equal in the isoelectronic spaces. So as we learned that cations are always less than the neutral atom, and the neutral atom is always less than the anion. So now in this set of isoelectronic spaces, we can just arrange them in the increasing order of their ionic radius, like F minus. And you can also take another element before it, that is O2 minus. So now let's arrange them in the increasing order of their ionic radius. So here, as the negative charge increases for anions, as the negative charge increases, the ionic radius increases. But whereas in the cations, as the positive charge increases, the number of the ionic radius decreases. So now let's arrange them. So here Al3 plus has greatest positive charge. So Al3 plus will have smallest ionic radius. And the next is 2 plus. Mg have 2 plus charge. So next one is Mg2 plus. And next is Na plus. And next is the neutral atom. And next is the anion. Here fluorine has the least charge, that is 1 minus. So we have F minus and 2 minus, which is greater than 1. 2 is greater than 1. So O2 minus have greatest ionic radius among given elements. And ionic radius and atomic radius in the isoelectronic spaces is the most asked question in JEE Mains and Advanced. So after completion of this atomic and ionic radius, now let's start the exercises which will just clear the concept the more. So the first question is O2 minus and silicon, that is O2 minus and Si4 plus are isoelectronic spaces. If the ionic radius of O2 minus is 1 angstrom, it's very important, let's color it. Then the ionic radius of Si4 plus will be. So here in the isoelectronic spaces, the negative charge, that is anion, has the more ionic radius compared to the cation. So the ionic radius of O2 minus is 1 angstrom. So as silicon Si4 plus is cation, the ionic radius of Si4 plus should be less than O2 minus, that is 1 angstrom. Ionic radius of Si4 plus is always less than 1 angstrom because the size of the cation is always less than the size of the anion. So here in the given options, first option is 1.4 angstroms, which is greater than 1 angstrom. So this will be the wrong option. And B1 is 0.41 angstrom. It will be the correct option because 0.41 is always less than 1. So B is the correct option. And whereas C, in the option C and D, it has more ionic radius. It is more than the 1 angstrom. So they are wrong options. So our answer is B. So here is our second question, that is, an element X is assumed to have 3 types of radii. Then their order is, the first option is crystal radius is greater than van der Waals radius greater than covalent radius. Second option is van der Waals radius greater than crystal radius greater than covalent radius. Then the third option is covalent radius is greater than crystal radius greater than van der Waals radius. Fourth option is van der Waals radius greater than covalent radius greater than crystal radius. So the answer to this question is, an important point to be noted is van der Waals radius is 40% greater than covalent radius. That is the reason why this van der Waals radius is measured in noble gases which have greater radius. And crystal radius is 10%, which is our third option. Here is the third question in front of us. The correct order of atomic radius is, first option beryllium greater than carbon greater than fluorine greater than neon. Second option is beryllium less than carbon less than fluorine less than neon. Third option is beryllium greater than carbon greater than fluorine less than neon. And fourth option is fluorine greater than neon greater than beryllium greater than carbon. The solution of this question is, here we have elements and this is of second group, this is of fourth group, this is of seventh group, and this is of eighth group. Sorry. And we know that across a period the atomic radius decreases. So actually many people will choose the option as beryllium greater than carbon greater than fluorine greater than neon. But the answer is, it is wrong. It is the wrong option. The first option is wrong. Because there will be an exemption. The 8th group elements have an exemption that they have more radius, more atomic radius than 7th group. See, the nuclear charge across the period increases. But whereas coming to the 8th group elements, these have no nuclear charge between the electrons. As they have no nuclear charge, the atomic radius will be greater than that of the 7th group elements. 7th group elements have the greatest nuclear charge, but coming to the 8th group elements, they doesn't have the nuclear charge. That's the reason why they have more radius than that of the 7th group elements. The correct order would be beryllium greater than carbon greater than fluorine less than neon. This is the correct, which is our third option. And here is our fourth question here. Atomic radii of fluorine and neon would be, the first option is 0.762 and 1.6 respectively. Second option is 1.6 and 1.6 respectively. Third option is 0.72 and 0.72 respectively. And fourth option is 1.6 and 0.762 respectively. So here, just now in the third question we have learned that the 7A group elements have less radius than 8th group elements. So according to that, fluorine have less radius than neon. And many people would think that we must just by heart that sizes of that atomic radius of elements, but actually there is no need to by heart the atomic radius for this question. Like, fluorine atomic radius is less than neon. So in the given option, the first option, 0.762 is less than 1.6. It is correct. So our correct option is first option. Whereas in the second option we have 1.6 and 1.6. But actually the fluorine and neon does not have the same atomic radius. So second option is wrong. And the third option is also wrong. And whereas in the fourth option, if you check, the fluorine atomic radii is greater than the neon. So 1.6 is never less than 0.762. Impossible. Yes or no? The last question, that is, the ionic size decreases in the order. Our first option is K plus greater than S2 minus greater than SC3 plus greater than V5 plus greater than Mn plus 7. Second option is S2 minus greater than K plus greater than SC3 plus greater than V5 plus greater than Mn plus 7. And the third option is Mn plus 7 greater than V5 plus greater than C3 plus greater than K plus greater than S2 minus. And the fourth option is Mn 7 plus greater than V5 plus greater than SC3 plus greater than S2 minus greater than K plus. So the solution of this question is, here they are isoelectronic species. If you just observe, they are isoelectronic species. K plus S2 minus SC3. So here are the species, and here we know that the greater the positive charge, lesser the ionic radius. So here Mn have greater positive charge, that is 7 plus. So Mn 7 plus have least ionic radius, and the next one is 5 plus. So V5 plus greater than SC3 plus. less than K plus, and anion have the largest ionic radius. This is the correct answer. So here second option is the correct one. Yes. So in this video we have learnt about the definition of ionic radius and variations of ionic radius in groups and periods, and about the isoelectronic spaces, variations of ionic radius in isoelectronic spaces, and we have done the exercises about the atomic radius and the ionic radius, which we have learnt about in the previous video. And in the next video we're gonna learn the next periodic property, that is ionization potential, and we're gonna do that exercises which will be most helpful. Thank you for watching this video. Please do like, share, comment and subscribe to my channel, and please do click on the bell icon for more updates. Bye bye.